better of organization. So it's correct if you took here any other address or any other address here is correct, but it's just to have a better, as I said, better organization. Let's take this here. All right, here I have 129 and 254. So the 129 will be the static here, and the 254 will be my router or my default gateway. Okay, let's do that now in the machines. That's it. My and my router is in the other one. Okay, already have some machines that I prepared this morning. And I will have 2 clients. All right, so let's take server 16 as a DHCP one, and I have the other one named server X here, gonna be my router. Of course, I need to assign network cards if I don't have them yet. I can work with VLANs, right? All right, so I already have here 2 cards with VLAN. One is VLAN 10, one is VLAN 20. Let's keep it that way. I can do 2 different switches. So VLAN 10 is the first network adapter, and I will go and put my addresses in there. I have all the template of the addresses in front of me. So let's take this one is VLAN 10, and this one is VLAN 20. Here's my VLAN 10. So what we said that the VLAN 10, or this side of the router, or this switch if you want, will be the 149, 192, 168, 149. 192, 168, 149. And of course, my subnet mask is 240 here, right? Put the right subnet mask. Click OK. And this one will be the 129. There we go. 100, 120, 29. And the subnet mask of this one was 255, 255, 255, 128. 172, 16, 100, 129. And here is 255, 120, 28. Okay, the IP addresses on this first server of DHCP is done. I can check my addresses here. There we go. Right. And be sure guys that the subnet mask is correct in each one, otherwise you will have conflicts of addresses or problems of routing or whatever. So this is 240 here and 120, 128 in this one. Okay, now all I need in this one is my DHCP, and they don't have any DHCP here, so I will add the role and features. Next. And DHCP. Next. Install. And after, I have to build 2 scoops. And those 2 scoops gonna take care about my default gateways. So let's go to the order of the main time and configure this one. I will need 2 cards connected both to the same switch. So I'm gonna change the switch here to Hamza. No, I'm just working in one switch with VLANs. All right. So this one will be VLAN 10. And I will disable this one few seconds just to be sure which one is VLAN 10, or otherwise I will do a mistake and after I will take hours to try to find this little sample thing. All right, it's already named S1, S2. So this one will be V10, and of course this one will be V22, V20. Okay, now I can put back my switch online and choose the ID of 20. One last check here. It's VLAN 10, right? Switch is Hamza, and this one is VLAN 20. All right. So we said that we're gonna work with the last addresses, just a matter of organization. I will have the 162 on VLAN 10, right? This is why I told you you draw it yesterday. Take a paper, put the plan in front of you, so you will not mix the addresses at all, right? So this one will be 192.168.100.162. And the subnet mask is 255.240. I don't have any of this. And VLAN 20 is 100.254. 100.254, right? So this one is 172.60.100.254. Of course, the subnet mask is 128 in this one, and I don't need that anymore. Of course, I can check my local server here. It's 162, 172.16, 100, 254 on VLAN 2. It's exactly what I planned for, right? It's exactly my plan here. So all the static addresses are correct. Of course, I'm gonna need a routing and remote access in this one. That's it. It's the only role that I need. Add roles, features, next, 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 and remote access. So this is the remote access and routing toolkit and install. Okay, let's go back to our DSCP here. Close. We're gonna commit to complete. Here is it. And we will build 2 scoops here, one in VLAN 1 and one in VLAN 10, and the other one is on VLAN 20. All right, click new scope. Let's say this one will be VLAN 10. Next. So the VLAN 10 is 192.168.100, and starting from 49 till 62. 49, 192.168.162. Of course, be sure here that your subnet mask match with the subnets 240. All right. Next, so see here, it's a /28. exactly as an exercise. So I put the /28, or I add manually here the /40 to 240. Yes, I have some exclusion. I need to exclude the first and the last address at least, because this is the addresses that I give to my servers, the router and the DHCP. So 192.168.149. Well, let's exclude, like, for example, 3 first addresses to clean up all that thing and have a brand new clear addresses on the 152. So my addresses will start from 50, 53, and I need to exclude also the last one because I gave that to my router. 160, 62. Add, right? So this is my exclusion. Do you want to blah blah blah? No, I will do it manually after, right? In my scope options. So this is my first scope, and let's configure a second scope. So this is VLAN 20, and VLAN 20 is the same, right? 172.16, 172.16, 100, and we were on 129, right? Starting from 129, going to 100 to 54. 129, 172, 16, 100, 254. Of course, should take care about my subnet mask. No, 255 here, and 120, 28. All right. This is my /20, 25 here, right? Next, I need to exclude the first one, 192.168, 100, 129. And let's exclude, for example, the 3 first addresses also. 172. Oh, sorry. Did I? Okay. I didn't do the name. 172.16, 100. And 16, 100. Let's say till 130. 31. So I will start by 32 directly here. And I need to exclude the last one, 172.16, 100. And the last one was 254. Add. All right. No, I will do them manually. Here we go. I have 2 wonderful scopes here of subnet, one in VLAN 10, one in VLAN 20. Now all I need inside is the scope options because they need to distribute to the clients a default gateway, or otherwise my 2 clients will not be able to use the router. Right? We explained that, we did it on many times on last modules. So I need to point my 2 clients here. Right? My 2 clients, I need them to be pointed on their default gateway to these addresses for each side. Okay, good. So VLAN 20, what is the default gateway of VLAN 20? It's the 100, 250, 254, right? See, VLAN 20, and to be able to use the router and pass through the communication. So it's the 100 to 250, 254. So this is the address that I have to distribute from my scope. So it's going to be 172.16, 100, 250, 254. This is my 003 on the VLAN 20. Okay, apply. Here we go. See, and on VLAN 10, the clients. Sorry, this is the switches. So the arrows are wrong, right? The client here and the client here. Okay, so the client should be pointed on his default gateway to the 160, 62, 162. So it's going to be 192, 168, 162. Add. Okay. Here we go. Activate. Activate. And here is my DSCP working very well. Okay, don't need that. All I need is to build a LAN routing. So routing and remote access. And configure and enable. Next. Custom configuration, LAN routing. Finish. And it will start the service of routing. My router will be working well. Here we go. And all I need now is to take some addresses on my clients. But before, I need to check if my clients are on the right VLANs with their network address. Okay. So let's query one here. And let's query one here also. Let's see this one. Where is it? Is in Hamza VLAN 20. All right, that's perfect. And this one should be Hamza VLAN 10. Here you go. I don't know if it's static or not or whatever. So I'm gonna check my adapter here. If it's not, okay, it's dynamic. That's perfect. And let's wait for the second one. CMD ipconfig. See, it's a wrong release from the old lab. I will release renew. There you go. See, he took the 32 because I did an exclusion till 31. This is my subnet mask 128, and this is my default gateway. He's pointing to the 102. 254. He's still stuck somewhere. Well, all right, let's release renew. Oh, I'm not logging with the administrator. Okay. Send out. All right. Okay, we don't need all those things. Of course, close everything here. Let's check it, the IP, if it's static or not. Of course, we're gonna find it that it's dynamic, because this is what we did on last lab. Turn up the options. There we go. Release a new. Here's it. Now we have IP config. See, 53 and 240, and he's pointing to the 62 default gateway. Let's ping this address and celebrate right after. Ping 172 16 100 132, and here we go. See, so the ping is working very well from VLAN 10 to VLAN 20, and let's ping from this 192.168.150.53, and here we go. All right, so this is the lab, guys. All about logic. First thing, you do your subnets, and after distribute the static addresses in a small plan in front of you, right? So you will not have a big mess with all the default gateways and the static things and static stuff, right? And after should be fine. Let's also talk about FLSM and VLSM. So variable length and fixed length of subnet mask, right? So just recap of subnetting of okay. 172.16.100.0, right? /25. Okay. /25, I borrowed 9. Just Karan, you follow? Right? I borrowed 9 bits. Okay. And my subnet mask is 255. 255. 255. 128. Okay. 128. So I already have that weird number. My block size will be 128. Because if I do 256 minus 128, I'm going to end up with 128. So I need to increment with this, right? So since even though those bits here are from the subnets, because I pushed 9, so 8 plus 1, so this part here should be reinitialized to 0. Okay. But I told you is correct. You just keep your 100 and you work with the second subnet of 100 because of we need to keep the lab ID 100, right? That's it. If you used 0, I told you, if you used 0, you used 100, both are correct. If you used 0, is correct. If you used 100, is correct. Okay, just to keep your lab ID here, we worked with the 100. Okay. Now, where you increment, you increment in the 4th position here, so you can reinitialize. So this is the subnet 00 0 128 10 128 to 0 to 128. So when we are on 100 here, we're gonna have 100, 0, 100, 128. This is what we're gonna have, right? So we worked with this one. That's it. But if you worked with this one, the second of this one, it's correct, right? This is the second here. Sorry, this is the third. Second is 0, 128. I jumped this one. Thanks. My pleasure. No problem. Good. So we worked with the 100 here just to keep the lab ID. This is the first, this is the second of the 100. That's it. But if you did it and you worked with this one, you're good. Okay, let's talk about something here. Fixed length, variable mask, variable length, subnet mask. VLSM, FLSM. You did your research yesterday, so we're gonna do it quickly here. What is the differences, right? The differences is when you subnet with VLSM, FLSM, sorry. We're gonna start with the fixed one. You're gonna have a network, a wall network, right? And you will separate it on equal networks, right? The block size is always the same, and we're gonna jump with that block size. So, for example, I will have let's make it simple. So we'll have 4 networks, and in each network I will have 64 minus 2, so 62 addresses, 62 computers. And you're going to see in all the wall networks here, the subnet mask will be the same. For example, is 255, 255, 255, 224. Right? So even I take the address from here or from here or from here or from here, they belong all to different networks. Those network size are equal. And the subnet mask they have is all the same. So this is basically the subnet thing that we were doing since we learned about subnet. Since the first time we learned about subnet, we're always cutting our wall network to equal subnetworks. Many of them, but all equal, right? So this is my FLSM, fixed length subnet mask. I will not change the subnet mask in each network. It's all the same. Now, VLSM is another story. VLSM is variable length subnet mask. So imagine if I have a network here, and I will split this network to many different zones. So we'll have this one, and after we'll have this one, and after we'll have something like this. Right? So see here for example, I'm gonna need 8 here. I will need 12. Here I will need 4. Here I will need 16, and in this one 128. Right. So this is how I'm gonna split it. I'll split it a little bit different. So my subnetworks are not all equal, and they have different size. So in this case, let's say for example this one is the network 192.168 100.0 slash 2027, right? So in this one, the subnet mask will be this and it will be equal everywhere. So my networks will be equal, right? Variable length subnet mask the subnet mask of this one will be different than the subnet mask of this one, will be different than the subnet mask of this one, will be different than the subnet mask of this one, and will be different than the subnet mask of this one. So let's say my whole network is 192.168.100.0, right? So mainly it was /24 class C. Now to get 12 or 8, for example, this one will be 255, 255, 255, and it's just examples, right? I'm just giving, I'm not doing the calcul or whatever. But let's say this one will be 252, 48. Right, 48. 4, this one will have the mask 255, 255, and 255, 252. 60 will have the same, or something like that, this one, for example. And 128, so this one will be 255, 255, 255, 128, and so go on. Right. So as you see here, the length of the subnet mask of each one is different because I'm reshaping my whole network to different subnets with different resources. And this is usually what we do. This is the real subnetting. Right. So I'm not wasting addresses. I need just 8 in this one. So I will get a subnet that is the most close to 8. We can have every time the exact amount of addresses that we need. I'm planning, for example, to have 24 computers in this department. So 24, the most close one, gonna be 32 block size. So I will have 30 computers available inside. I need to design my network on that one because it's always, 4, 8, 16, something, right? But if I need 12 here, I will not take the network that split on 8, 8, 8, 8. I will take the network that split on 16. Okay, and so go on. In 4, I will take the one that split on 4. And so go on and so on, right? This one split it on 2, I will have 120, 28. Now, how to deal with this? And for example, I have a plan first, right? So let's say I need a department that, or I'm in a company, I'm gonna need something like this. I will need at least 3 subnets or 2 subnets, and I will need on these 2 subnets, let's say at least 70 computer in each one, right? And also in my company, I will need another 3 subnets, and in each subnet, I'm gonna have I don't know, 300 computer in each one. So basically, when you are building a network, this is the data that you have, right? What you have your purpose, your objective. I need 300 in this one. I need something like that, right? So it's not about subnet masks. It's not about IP addresses. It's about the equipment and how big the classrooms or whatever, right? So this is the first number that you're gonna deal with, are those things, right? I need a department separated one for a network design. I need another department here for medical courses. I need whatever, pharmacy, right? So this is the logic that you deal with at first. Now, to be able to find what is the most optimum networks and subnets to work with, right? what is the most optimum network and subnets to work with based on this data right here, right? Okay, so here I need to find the number of bits of subnets that gonna give me 2 subnets, and I need to find the number of bits of hosts that gonna give me 70 or almost 70, the most close to it, right? I need to find this. I need to find this. How many bits that they're gonna give me 4 subnets, and how many bits they're gonna give me 300 PCs inside. Okay. Well, we already know the equations for all those things. So if you're gonna solve them, you will find all the structure of the bits in your calculator, right? So 2 subnets. The number of subnets is 2 power, let's say m, right? For subnet, 2 power m. Remember the equation. For the subnets, it's 2 power n or m. Let's make it different because I don't want to mix you. It's not the same n. This one is the number of bits of subnets. The other is the number of bits of hosts. And the other equation for the host is 2 power n minus 2. We already worked with those. Remember the tables that we solved yesterday? We did it a lot. And I was asking and asking and asking again, you one by one, this question. How many bits do I have here? What is the equation? What you did to find it? Remember, those equations, they're going to help me to solve these problems. Right? So here, for example, I need 2 subnets. So this 2 power m should be bigger or equal to. So if I solve this equation, I can find what is the number of m. And here is 70. So I'm working on the first example here, right? So 70 is 2 power n minus 2 should be bigger or equal 70. So if I solve this equation also, I will know how many bits for the hosts should remain. And same thing here. 3, so 2 power m, this is number of bits of hosts, should be bigger or equal 3. And here it's 2 power n minus 2 should be bigger or equal 300. So if I solve these equations, I will find and figure out how many bits I have to borrow and how many bits I need to let remain on the structure of the 32. Okay. Well, let's do it quickly here. So 2 power m minus 2, see, I need to be the most close to 2, so bigger or equal. So always I will look for the equal or the first bigger, right? Here I know that 2 power 1, it's the most closest one, right? Because I have 2, 4, 8, and so on. If I put 0 here, I will end up with 1. But I need to find one is the bigger or closest between those ones, because after I can go 16 and so go on. All right. So what is the most closest to 2? Is the 2. So 2, to get it, it's a power 1, right? So I need to borrow 1 bit, right? I need to borrow at least 1 bit to get 2 subnets. Okay. 2 power n minus 2, bigger or equal 70. So this one become 2 power n bigger or equal 72. Sorry. It's just the -2. -2, I push it to the other side, it will be +2 here, positive, right? The equation, it's mathematic, right? So this one will be 70, 72. Now I need to find which n is the most closest to this 70, 72. Well, let's take the calculator here and let's do it. All right, so if I have 2 power 2 power 2, where the hell is power x? Yeah, 2 power 2, 4 power 2. So this is power 2, this is power 4, power 3, sorry, power 4, 5, 6, 7. Okay, I have 64 before and after is 128. I don't have that much, right? So let's do it again. This is 2 times 2. So this is power 2, 1, power 2, power 3, power 4, power 5, power 6. Still not enough. Power 6, still not enough. I'm smaller, right? Power 6, power 7. This one is the most bigger one here. So n should be 7 bits remain. So I need to remain at least 7 bits here. So 7 bits for the host. 7 bits for the hosts. I'm done. If I find how many bits I need to borrow and how many bits I need to remain, so I can build a computer that can have the most optimum one, that can have 2 subnets and at least 70 computers inside will be with the subnet mask, this one. So I need to borrow 1 and remain 7. So if I have, for example, 192.168.100.0/24 at the beginning, here I will borrow 1 from this 8. Here is it. I will have my 2 subnets, and the remain is 7 bits. The remain is 7 bits. So it will work with the subnet mask 128. Okay, so I have 2 subnets here with this subnet mask. And after, I will need other 3 subnets with 300. And I will solve the equation here. Right. So 2 power m bigger or equal 3. If I put 1, 2 still smaller. If I put 2 here, so this is 4. This is good. So I need at least to borrow 2 bits. Okay, because 2 power 2 gonna give me 4. 4 is the most close, bigger or equal to 3. So m here should be 2 bits. So I need to borrow at least 2 bits. 300 minus 2. So it's gonna be 302. So 2 power n bigger or equal 302. Let's take the calculator. And see it. So this is power 2. 3, 4, 5, 6, 7, 8, 9. Because if it's still at 8, I have 256, and it's still smaller than 302. So the most closest one, double of 2, the most close double of 2 to this value is power 9, right? So my n here should be 9-bit. Okay. So I need at least to have 9 bits for the hosts, at least, of course, and 2 bits that I borrow on to push, 2 bits to push for the network. Okay, can I do that? Can I do it exactly like this? Like let in 9. So you remember the structure of the IP. I don't have that much freedom. So 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4, 1, 2, 3, 4. Right. At least I'm gonna need 9 bits here. At least. So here I have a choice. I have a choice to take more subnets or to take more computers in each subnet and keep it at 3 subnet or 4 subnets, because at least 2 bits. Right. But I will never be able to get an exact 3 subnets that they have this, because if I take 1, 2, 3, 4, 1, 2, 3, 4, so this is 8. All right, this is the host bits. This is my host bits, right? So 9 bits for the hosts. But as you can see, I'm not able to just take a subnet here and push these 2 or whatever. It doesn't really have a meaning. So the logic behind is to take the 8. You see 8, so it's 255. 8 is 255, and I need those. So I will have more than 3 subnets. I don't have a choice. Or I can push 2 here, but I need bigger than 9 here. So I will end up with bigger than 9. I don't have a choice. But this is the most optimum network that can give me this result. This is the most closest network to this need, right? So if I take here just 2 bits to push, all right, I will end up with 8 plus 6 here of hosts. So I will have much more hosts here, much more hosts, but I will have my three subnets in here. Okay, so I have a choice depending or whatever. And this is the work of a network administrator. So I can see that I will never have a department bigger than 300. 300 is enough. But maybe I will need more subnets in the future, right? Ooh, well, this is better. So I'm going to take the 9 here, and I will choose this one and push all those. And for the future work, I can have more other subnets if I need them, right? And keep my 9 here. Or if I say that we'll never have extra departments, but maybe we'll have more customers in each department, right? So maybe 300 will not be enough in the future. We need more computers in each department. But it's okay. We already have human resource. We already have I don't know, right? So my company will stay like that with the departments, but maybe the departments will grow bigger and bigger. Right. So it depends. It depends on the situation. But this is how we solve this problem. So usually, maybe even in the CCNA exam or whatever, this is the type of the question that they're gonna ask you. They will not give you subnet mask. They will not give you whatever. Usually, right? Depend. But usually they will give you a scenario, right? They will tell you, I need a department. In each department, I will have 12 computers. I'm gonna need 3 subnets, and in other one, blah blah blah. So if I choose this one, you will see that my address now, I will submit it on another kind of subnet mask. So I'm pushing here 1, 2, 3, 4, 5, 6, 7 to 52. So you see, this one and this one are not equal. I'm working with VLSAM here. So I took the whole network, I split it in two, right? Two equal here. So this is the subnet mask of 120.24. Yeah, 254. Sorry here. Yeah, it's okay. So what I was doing. God. Yeah, I have two subnets here, two subnets of 70 computers. So I can put my 70 computer in this one, and this one. And the subnet mask of these two here is 255, 255, 128. Or imagine if he told me just I need one network here. So I will just not need the other one, I will keep one, right? And they need three subnets of 3. So each one will be 300 here and here and here. Right. So I subnet this one on 255, 255, 254.0. Okay. Or even here, he will take just one, for example. I don't need subnet, so I will take this one. And this one. And after he will say, I will need another one of 12 computers here. Right? So I need to solve this equation here. 2 power n minus 2 bigger or equal 12. And I will find the next subnet with the next subnet mask. And after he will say, I need the 53 computer. Right? It's the same thing. I need this one and solve it. This equation here, 2 power n minus 2 bigger or equal 53, and I will find what is the most close subnet mask. But as you can see here, my original network was 9192.168.100.0/24, something like that. So that was my original network, but I split it different quantities with different subnet mask each time to give me the most closest situation to the situation that I need. Okay, this is VLSM, variable length subnet mask. The subnet mask doesn't have the same length like we did before. Subnet mask is fixed, 255, 255, 255, 128. It's exactly the same amount of bits of subnet mask that we are subnetting with each part of the network. But in this one, no. We play with the subnet mask to make it smaller or make it bigger or have more subnets or have less subnets, right? It's the same network, it's the same company, it's the same network administrator, but he is using different variable of subnet mask to be able to split the network depending the need, right? All right. Do you have any question about this, guys? Do you have any question about this? Please feel free to ask your question if you have any question. Hello, hello. Question, people? Nothing. All right, good. Well, I will open to you the next chapter. And don't forget your attendance, people, right? Please don't forget your attendance here, query 1. So next chapter will be chapter 2 VPN. And you will end up with this document right here. Right? So this is what we're going to cover. It's a small, it's not that big. And we will finish this part when we'll be done. Is it clear? The VLSM was clear for you guys? The variable length, subnet mask? Was clear? It's easy, right? It's just the equation that we were using. Now we're gonna have the result of those equations. So we will back. That's it. We'll look for that n somewhere to figure out how many bits we need, and from that we get to the subnet mask. Okay, the document is already online, and it's almost 10, so I don't want to start and stop in the middle. We're gonna start and finish it at once. Let's take our break quickly right now before dealing with the content of this document. It's gonna be fast. We're gonna talk about the encryptions and those stuff. Let's take a break 30 minutes from now, right? 30 minutes, it's 10 minus 15 here. It's 15 to 10. We're gonna come back at 10:15. 10:15. Okay, guys, see you in 30 minutes. I will notify you in Kaizala, of course. I will let everything connected, just disable my camera and my microphone. See you.